In the last lesson, we learned if a molecule has, say, 3 bromines on it, that we represent the 3 bromines with a little subscript 3. Now, in this lesson, what we're going to look at is how could you, as a chemist, completely predict what the formula was for an ionic compound, just simply using a periodic table. And that's a pretty powerful tool to be able to predict what kind of behavior compounds will actually have in the real world. So let's get into that, and it has an awful lot to do with knowing the charges of those particular ions. Now we're going to come back at the end also and look at how do we name ionic compounds. If you've ever noticed, chemistry names tend to be kind of unusual sounding, like potassium fluoride. And you might wonder, why not fluorine, right? Because the element's fluorine, and we'll get to that at the end of this lesson. All right, so let's get started here. If I can get it to go to the next slide. All right, so the key thing to know here about this, and let me move me a little bit so you can see this, is ionic compounds obviously are called ionic compounds because they form between ions. Things need to be charged, like iron 2 plus or bromine minus or N3 minus. We're not talking neutral compounds. The electrons have to be transferred. They are not being shared like they are in covalent compounds. So the covalent compounds we're going to leave for about a week, week and a half. We'll come back to them. All of the ones we're going to be looking at here are all charged. Now, the other thing to notice, and I think you already know this, is that they have to be oppositely charged to form compounds. If you think about it, bromine and nitrogen here, they're not going to bond. They're the same charge, right? We know that the same charge repels, right? They have to be attracted to each other. So iron could bond with bromine, sure, that's a possibility. Iron could bond with nitrogen, but it's not going to be able to form an ionic bond between two negative compounds. And so if you ever like working on a worksheet or something like that, and you're like, wait a minute, both of these are negative, you know that I made a mistake. And the same goes if both of them are positive. They just can't bond together because they're not going to be attracted to each other. Now, the other thing that I want to bring up while we're here is you might wonder, how did they become charged? Well, remember, the negative ones gained electrons. Let's look at this example. We're just going to focus on iron and bromine. But you remember that the negative ones gained electrons. So imagine that you have an iron and you have a bromine. If bromine is negative, it's because iron gave an electron to bromine. That's how it became negative, right? And this became positive as it did that. They became charged by giving and taking electrons from each other. That's super important to know about all of this. All right, so let me erase the screen here, and let's look at how could we, just simply by looking at the charges on those two compounds, determine the formula. Well, I have some tips that we're going to run through as we go as we do this. So the first thing is, if you're going to write a formula, the cation has to go on the left. In other words, the positive ion has to go on the left. So I am going to put iron first and then bromine. And all we're trying to figure out is what these numbers are. Is this a 2 or a 3 or is that a 4? Right? We're trying to figure out how many of each one of those two there are. So let me get rid of that again, and let's go back to our formula. And we know that we're just trying to find what those numbers are. Hold on, I got to pause the video. I don't know what my dog's doing right now. She's just chewing on her bone. I thought she was destroying something. Okay, so let's get back into this. So the cation goes on the left, and we're just trying to figure out how many of each one we've got. Now we're going to use what I call an ion chart. Chemists don't really call it this, but we're going to sort of balance the charge on each side. Like right now, if I were to think about this for a second, right now the overall charge over here is 2 plus, and the overall charge on the negative side is 1 minus. That's not even. We're trying to make the scale sort of even, right? I would like them to be the same. And so what I'm going to do is, because I have 2 positives and only 1 negative, I'm going to add another negative. So I'm going to add a whole nother Br minus. Now that, of course, will mean I have 2 negative things, so now my tally on this side is 2 minus. But the deal is, bromine is -1 always. I can't change its charge. So if I needed it to be 3 minus, I'd add another bromine. I can't just all of a sudden decide bromine is 2 minus or 4 minus or something like that. It has to, all of the ones in the list have to be the same charge. Okay, so now the 2 bromines give me 2 minus, the iron is 2 plus, and now I know if I look at these two, the positives are the same sort of balance as the negatives, which means the compound is neutral, and that is super important. It has to be neutral. That's a requirement. And now we're done and we're ready to figure out what our formula is. Well, if I want to figure out what the formula is, look, there was 1 iron. So I'm going to put a 1 right there. and there were 2 bromines. It has nothing to do with the charge. It's the fact that there were 2 bromines. And so my formula when I get done will be FeBr2 because we don't often write the 1. That's it. That's how we figure out the formula based on the charge. Let's try another one. It gets a lot easier the more you do. Let's look at this one. So first, when I write my formula, is Na or N going to go first in my formula? Na, because it's the cation. Now I say that because sometimes they don't have to be listed in this order. We could have put the N minus 3 over there. Doesn't matter, right? So the Na goes first, and we're just trying to figure out those numbers. Now, I have, if I were to tally this up right now, I only have 1 positive. See that 1 positive? And I have 3 negatives. Do I need more positives or negatives? I definitely need more positives. So I'm going to do another sodium plus in my list, my ion counting list. And now I'm up to 2 positive. But we're not neutral yet. They're not balanced, right? The positives are coming up pretty quickly, but it's going to take another one. And now I have a total of 3 positives that matches my negatives. There we go. I've got a neutral compound. There's no charge. And now we can figure out what our formula is. Let me get a different color marker. We're going to go with green. How many sodiums go down here? Well, I see 1, 2, 3 sodiums. So I'm going to put a 3 there. And I saw only 1 nitrogen. Now this is really important. The subscript tells us how many of each ion we have. Do you see that I only put a 1 there? Because there was 1 nitrogen. I didn't put a 3 because 3 is the charge. It's not how many there are. It's the charge. It's like a feeling, right? It's like, whoa, I feel really negative. But there was only 1 nitrogen, so that's why I put the 1 there. So we're using the charge to figure out how many of each ion we need. But other than that, the charge doesn't end up in the final product. Notice there are no positives or negatives. No positives or negatives in the final product because those are just telling us how many of each type we have. All right, it's going to get easier as we go. Let's try another one. So I want you to try this one. I want you to get a piece of paper out. I want you to make an ion counting list and decide, do you need more positives or negatives? And then I want you to type in the formula you've got. I do want you to type in the formula. If you're not feeling super comfortable, remember it's going to get easier as we go, but I do want you to put in your answer. If you don't get an answer, I want you to write in what you're confused about. Okay, let's do our ion counting list. Right now, we have 2 positives and 1 negative. That's not balanced. Which side needs more, the positives or negatives? The negatives. That's absolutely right. So I'm going to go Cl minus. Now I have 2 negatives, so I'm up to 2 negatives. And there we go. Our positive and negatives are balanced. Our compound is neutral, and we can write our formula. Calcium does go first because it was the positive ion. How many calciums were there? Just 1, and we could put a 1 there if we want to, but we don't have to. How many chlorines were there? 2, so I put a 2 like that, and typically we drop the 1, right? We don't really write the 1, and there you go. That compound is CaCl2. Let's try another one. Now, when we get to this point, you're going to see that you need to know the charges. If I say to you, let's form a compound between gallium, which is, by the way, right here, I think, if I can write on this, is right there, and iodine, you need to know those charges. If you've never noticed this pattern when we were doing ions, remember lithium loses 1 electron to become isoelectronic with helium? Therefore, it's +1, just like all the alkali metals are. Magnesium loses 2 electrons to become isoelectronic with neon, and all of the alkaline earth metals are +2. So if you have your periodic table, it would be a good idea to get it out and label it. The transition metals we're going to skip for now. We're going to come back later and find out why. A little hint, they have more than 1 possible charge. This column, all of them in here are +3. This column, carbon's column, they could be +4 or -4. We'll get to that. And then nitrogen's column is -3. So if I find arsenic, I'll do -3. Oxygen's column is -2, so if you have selenium, you'd say it's -2. And fluorine's column is -1, and of course the noble gases are 0 because they don't gain or lose electrons. All right, so gallium's right here. According to this chart, it has a charge of 3+. Iodine has a charge of 1-. Now I want you to write the formula and type it in. All right, did you get this? It looks to me like we have way more positives than we have negatives. We need to increase our negative side. How many iodines is it going to take? Well, 2 is not enough. It's going to take 3, and so that gets us up to 3-, and sure enough, we have a neutral compound. So now we can write our formula. It's GAI, because the positive goes first. How many galliums? Just one, and I don't think I'm going to write the number. How many iodines? 3, and I'm going to write it as a little subscript like that, and there we go. We've got a good formula for that compound. Let's try another one. And this time I'm not going to give you the charges. You have to figure out what they are. So I want you to write the charges on your paper, and I want you to write an ion counting list, and then type in the formula you get. Okay, I think magnesium is right here. As all alkaline earth metals, it has a 2 positive charge. By the way, you can see me reversing this. It is traditional to put the number first, but it really doesn't matter. If you wrote +2, no big deal. Oxygen is 2 minus. And if I were going to say, okay, I add up my total of 2 positives, 2 negatives, boy, right now it's neutral. So we do not need to add any more. So when we write our formula, how many magnesiums were there? Just 1. I don't think I'm going to write the 1. How many oxygens? Just 1. I don't think I'm going to write the 1. And we're done. There we go. There's our formula. We're doing pretty darn good. Let's look at this one. With this one, I want you to figure out the charges. I'll show you where they are. There's aluminum and there's sulfur. I want you to figure out the charges, do an ion counting list, and then write the formula. Well, aluminum, according to the periodic table, is 3 plus. Sulfur is 2 minus. Now this one's a little bit tricky. If you got stuck on this one, watch what happens here. This is 3 plus. This is 2 minus. Clearly we need more negatives, right? We don't have enough negatives. But I can't do sulfur 1 minus because that's not the charge of sulfur. Sulfur is 2 minus. Now I have a total of 4 negatives. Which side needs more now? The positives do. So I'm going to do another aluminum. Now you might think I really just want to do 1 plus, but that's not the charge of aluminum. Aluminum is 3 plus. So now we have a total of 6 plus. Now we're still not neutral, are we? We now need more negatives. So we got to do another sulfur, and there we go, 2, 4, 6. We're now up to 6 negative, and we have 6 positive. There we go. Now we're neutral, and we can write our formula. That was a tricky one. Now we knew we had to bring that one up sooner or later. There's 2 aluminums, and I see 3 sulfurs. So I'm going to put like that, and there we go. There's our finished formula. That is the formula that would form between aluminum and sulfur. Pretty darn good. Let's try this one out. The atoms are right here and right there. I want you to write their charges and write in the formula. K is 1 plus, or plus 1. I wrote it backwards that time. Nitrogen is 3 minus. Let's see. We have 1 plus and 3 minus. Which side needs more? Definitely the potassiums. I'm going to need another one. And I think I'm going to need another one. That gets me up to 3 plus. There we go. That's neutral. I'm just going to write it as neutral. And my formula will be K3N. Why? Because there's 1, 2, 3 Ks and only 1 N. Boom. There we go. All right. I want you to figure out the charges. Where's barium? Right there. And phosphorus is right there. And then write a formula. This is one of those tricky ones. It's not that tricky, but it keeps you on your toes a little bit. I got 2 plus according to the chart here and 3 minus. Now if I were going to do this, you go right away, you go, oh no, I think this is going to be a little hard. But clearly we need, do it one step at a time. We need more positives. There's less positives than the negatives. So, but the deal is if it was 2 plus in the beginning, it's got to be 2 plus here. Now that gets us up to 4 plus, and you can see now the positives are winning. So clearly we need to add another negative. That gets us up to 6 minus. Now the negatives are winning, so we're going to have to add another one of these. And that's the deal, is you can't change the charge. Now you're up to 6 plus, and boom, there you go. You have a neutral compound. It's going to be, well, let's see, how many bariums did it take? I see 3. 1, 2, 3. How many phosphoruses or phosphori? 2. And we've got our formula. By the way, you might hear in your chemistry studies about an idea called crisscross, the crisscross method. There's a reason we don't do the crisscross method in this class, and I will show it to you later. If you learn it from a friend, I'll show you the problem with the crisscross method. Okay, so in this lesson, all we did was we learned to write formulas of ionic compounds. But believe it or not, we're not done, because we're going to learn to name ionic compounds right now. It's easy. The deal with naming is, let's go back to this one. In ionic naming, you might think that this is barium phosphorus, but it's not. The end always changes. The anion, this side always changes with an "ide" ending. Barium phosphide. Now, sometimes people worry about, wait a minute, do I do barium phosphoride or barium phosphide? Generally speaking, it's the shorter of the two. Let's try this one. This one I think would be potassium. We don't do anything to the first part. And how would it end? Not nitrogen, nitride, right? We always end the second part with "ide." Now, if you thought nitrogide, that's fine, but usually it's the shorter of the two, nitride. Let's look at this one. This one, don't do anything to the beginning. It's aluminum, but what would be the second word? Aluminum. I spelled that wrong. Aluminum. And the ending would not be sulfur. It would be sulfide. That's right, if you got that. If you said sulfuride, no big deal, but usually it's the shorter of the two. Let's try this one. I want you to type in the whole name. Did you get magnesium? Remember, the first part doesn't change. Oxide. Yep, oxide. Not oxygen, not magnesium oxygen, not magnesium oxoride. It's the shortest version, oxide. By the way, this is an iodine, so you got to take a guess at what you think it would be. It would be gallium, and type in the rest. Iodide. Sounds like you have a cold, right? Instead of iodine, iodide, because it always ends in "ide." Let's try this one. I want you to type in what you think the name would be. Calcium chloride, right? Not chlorine, chloride. Pretty good. So yeah, when it's ended, when you hear about, there's fluoride in toothpaste, that's really just fluorine that's negatively charged. All right, let's try this one right here, this compound. Sodium nitride. Right? Sodium nitride. Let's do this one really quick. Type in the answer. I think this will be our last one. Iron bromide. Right? Not bromine, bromide. All right, great job. So today, what did we learn today? We learned a couple things. We learned how to write, we learned how to write formulas for ionic compounds, and we learned how to name those compounds by changing the negative ion to "ide." Nice job.